Hello everyone. So today let us see the next program for simulating in NS2. Before I start with the simulation on this example, I request everyone to go through this basics of this simulation in NS2. It is titled as Working with NS2, a beginner approach in the YouTube. Please go through this complete video, which is the pure basics of working with the NS2 by using the TCL language. So please go through this before we begin the next experiment. So coming to the next experiment, here it is. So it says that the program problem, here it is, you will have to create the 4 nodes. So and try to understand the problem completely. So here you need to create this a network with the 4 nodes, and that the 4 nodes should be named as N0 to the N3, that is N0, N1, N2 and N3, wherein out of this, remember, N0 and N1 should act as a source node, whereas N2 is the destination and N3 is the destination and N2 is the intermediate router, which is a connecting device. So remember, these are the 2 source nodes, N0 and N1 as a source nodes, and N3 is the destination node where the communication will end up, and N2 will be only acting as an intermediate router where the communication will never begin. Next, it is also given as you need to connect the N0 and N1 to the N3 via N2. So you need 3 links. And it is given that how to connect them. It is by using the duplex link. You need to connect them by using duplex links with the respective capacity of bandwidth and the delay, as you will have to connect N0 to the N1 you need to connect N0 and N1 to the N3 via N2, as have a link between N0 and N2 with the bandwidth as 10 Mbps and the delay as 10 milliseconds. Again, have second link between N1 and N2 with the bandwidth as 10 Kbps and the delay as 100 milliseconds. The third link between N2 and N3 with the bandwidth as 10 Kbps and the delay as 100 milliseconds. So like this, you try to have a 3 links based on the given problem. Try to have these 3 links. Once the links are ready, once after you connected them, now you need to create the agents. How to create the agents? Here, as in the problem it is said that you need to create one agent. Which agent? It is the TCP agent and attached to the N0. And when you connect TCP agent to the N0, so it means to say that N0 will become the source node. You understand? N0 will become the source node. When N0 becomes source node, the destination node is nothing else, N3. So I hope you understood from the previous video such that if the TCP agent is the N0, then the receiver, which is the destination agent, is the TCP sync agent. TCP sync agent is the N3, which is the destination. So wherein you created the TCP service. You created the TCP service between what? Between the between N0 you created between N0 to, so there is a connection to the N2 as well, and that to the N3. So via this N0 to the N3, from N0 to the N3 via N2, you have a TCP communication, wherein N0 will be acting as a TCP source agent and N3 will be acting as a TCP sync agent for destination, for receiving the data. So for this we created the TCP service. Then again in the second part, so if you see in the next part of the question, it is again as usual you need to build the UDP agent between what? Again as usual you need to have a UDP agent between N1. So N1 will be acting as a UDP source agent. You will be creating N1 as a UDP source agent, wherein as usual N3 will be acting as the destination agent. And I hope you remember, in case of UDP, so in case of UDP, destination will be the null agent, wherein in case of TCP, the destination is the TCP sync agent. So from this you try to make it out that N0 and N1 are the two sources, whereas the destination is common for both the communications. So whatever it is sent by N0 will be collected by the N3 itself, and whatever it is sent by the N1 again will be received by the N3 itself. So the common destination with for both source nodes, wherein both the source nodes are sending to the common destination via the common router. So this is what the depiction, or you can say the topology, how we are going to connect. So by now we created the agents. Now it is the time for creating the application. So I hope you know that for the TCP service we do make use of the FTP application. For the UDP it is the CBR traffic application. So this is what the creating the applications, FTP application for TCP, whereas CBR traffic application for the UDP. So that is how we'll be providing those services as well, application services. Then next point is that we need to fix the size of the packet. We need to fix the size of the packet and the time interval for both TCP and the UDP service. Here it is given that you are supposed to have a TCP, with respect to TCP service, you are supposed to have a packet size as 200 bytes and the time interval of 0.01 seconds. Wherein for the UDP service, you are supposed to have a packet size as 300 bytes, wherein the time interval as 0.001 seconds. So that is what it is given. Next thing is here, the last part of the question. When to start the CBR? You need to start the CBR at the 0.1 second, wherein FTP should start at 0.3 seconds, wherein both should end at the 0.5 second. For this, we are supposed to write the TCL script. So that's how I just divided the complete problem into the multiple pieces, wherein this will be very much useful while writing the TCL script, because based on the flow of this problem itself we will be start writing the program TCL script. So that let's see that before we see that, remember we are creating the 4 nodes. Among those 4 nodes, 2 nodes will be acting as 2 sources and one common destination via the common connecting device, which is the router. And how to connect? It is by using the duplex links. What is the bandwidth and the delay of those 3 links, which is already given here, because you remember from N0 to the N2 we need 1 link, from N1 to the N2 we need one link, whereas from N2 to the N3 we need 1 more link. So total there will be 3 links necessity. And it is also given which is the TCP service, which is the UDP service, and also it is also mentioned that in the problem itself FTP should be applied for the TCP, whereas CBR traffic application should be applied for the UDP. And also it is mentioned that what is the packet size and the time interval in both the cases, in the TCP and also the UDP. And the last part of the question, it says that when to start the CBR, when to start the FTP, when to stop both. So it is everything it is mentioned. So now let us get into the let us start writing the TCL script. So here let me make use of the Fedora. So in this perspective, as soon as if I say that I will have to create a file, so I just create the file name as 2.tcl, because the TCL is the extension, the tickle. So I will create the tickle extension tc2.tcl. Now first let me create. So first let us set up for the simulator. So let me set up the simulator. For setting up the simulator, I hope you know the command. Just set ns is a variable. So set ns new simulator. Remember this s is caps. So I'll create a new simulator. Once after I created the new simulator, then I'll be setting for the trace file. I'll just create a trf as a pointer. Trf open. What to open? It is the 2.tr, because so 2.tr is the name of the trace file, and I'm opening that with the write mode. So I want to open that with the write mode. Right after this, then I'll in the same way. So I need to connect that. So I just need to connect that. In the other way, I mean to say that I need to trace that. So for which I'll be using the trace all, and which to trace? It is this TRF. This TRF I supposed to trace. So wherein this TRF is the pointer now, so that I need to trace it. So then now once after I am done with this, next I need to create the NAM file. However, I created the trace file. So set, I'll just say that NAMF, wherein I'll just open the 2.nam. Remember this file names, which is very important, because these are the two output files, which is 2.tr and 2.nam, which are pointed by the TRF, which will be pointing to the 2.tr, and the nam, which NAMF will be pointing to the 2.nam. I hope you studied this in my basic video. So then I'll have to trace that as well, which is nam trace all. So what I need to trace, it is a NAMF. So like that I just created the simulator. Now next let me create the nodes. So remember how many nodes I need to create. I need to create 4 nodes, which are named as N0. So what is that? It is the NS node. Again as usual, set N1, set N1 NS node. Again I have set N2 node. Before node it is $NS node. Again in the same way, set N3 $NS node. So like that I just created the 4 nodes. So once after I'm done with creating the nodes, let me label these. So let me label the nodes. So I'll call it as a labeling. So what I'm going to do, let me label the N0 as what? So let me label it as a TCP source. Let me label this as TCP source. Then let me label the N1 as a label as what? UDP source. I hope you remembered. So these are the 2 nodes which will be acting as a source nodes. So then let me label the next node. Which is the next node? It is the N2 as what? Label. So N2 will be acting as intermediate router, if you remember. So let me call it as a router. Again N3, which will be acting as a destination. So I'll call it as a destination. So like this I'm done with the labeling of the nodes. Okay, so I'm just done with the labeling of the nodes. So then once after I'm done with the labeling of the nodes, now let us go with the connecting them through the links. So how do I connect by making use of the links? So now let us see that connecting the links. So I'll call it as a connecting using links. I hope you know that is why I'm going to say how we are going to connect. We will be connecting by using the duplex links. Even if you want, you just have a look into the question again here. So how to connect? I need to connect N0 to the N2 with the bandwidth as what? 10 Kbps and the 10 milliseconds. Then again I need to connect N1 and N2 with the 10 Kbps. Whereas here it was 10 Mbps, here it is 10 Kbps with the 100 milliseconds, and finally it will be again 10 Kbps and the 100 milliseconds. So I need to connect in the same fashion. So I need to connect what? So first it is NS, and I need to make use of duplex link. I need to make use of duplex link between what? Duplex link between N0 and what? N2 with what? 10 MB. It is 10 MB Mbps. Again, what is the delay? It is 10 milliseconds, and I should make use of the drop tail queue handling mechanism. Drop tail. So like this, I need to have a I need to have for two more nodes. I need to have it for the two more nodes as between between duplex link between N0 and N1. What is between N0 and N1? It is what? 10 kb instead of 10 MB. It is 10 kb, and I hope you remember the delay is 100 milliseconds. Again the last one again 100 milliseconds, and this is again the 10 kb. And what about you if I am just making so little faster? I hope you are getting. So what we did, we created the link between N0 and N2, and this is what N1 and N2. N1 and N2. So then between the N2 and N3. So that's how we just created the three links here. Once after you are done with the creating the three links, now let us create the agents. So for the purpose of creating the agents, so if you want to create the agents, so for creating the agents, I hope you remember what kind of agents we are going to, or we need to create. So remember, we need to create the two different types of agents. So which are the two different types of agents which is supposed to create? So you just look it from this. So I need to create the two agents. One agent is with respect to a TCP service, and one more agent with respect to UDP service. And so the two agents I need to connect between the two source nodes, which is N0 and N1, wherein N3 will be acting as the common destination for both. So N3 will be acting as a common destination for both. So I need to have both sync agents and also the null agents both for the N3. So just remember that in the same fashion we are going to create the agents as well right now. So starting with let me start with the creating the TCP agent. So I'll just say the set TCP. So what is this? It is the agent. So I'll say that new agent / TCP. So TCP agent is created. Then I need to connect that. So that is by making use of the NS attach agent. So to which node I need to attach this? Remember, I need to attach this to the N0. What I am attaching? I am attaching the TCP, which is I am attaching the TCP pointer to the N0. So then once after I just attached the TCP agent, so then I need to create the respective sync agent. So for the purpose of creating the sync agent, so how do I create? Again as usual, set sync new, it is agent. But what agent? It is the TCP, sync, it is the TCP sync agent that we are going to attach. What I am going to do, I need to attach what? To which node? It is the attach agent. To which node? It is to the N3. Remember, because the common destination N3. And what I am attaching? It is the sync. So like this, I have just created the TCP agent at the source, and which is N0, and the sync agent at the destination. So wherein I need to create the application as well. So which is, so I will say it as FTP. So FTP attach. Before attaching, so I need to create set FTP. So set FTP new. So application. So new application. On what application? It is the FTP application. So then I'll be attaching that. That's what. So FTP attach agent $TCP. So this is what I'm done with the TCP service. So the next is that I need to go with the UDP service. So I'll just create the UDP new agent / UDP. So which is the UDP agent. So this is what I just created the UDP agents. Again as usual, I need to connect that. So attach. Yeah, it's supposed to be clear with the spelling as well. Attach agent, and which agent I need to attach this UDP agent right now. It is to the N1. So I need to attach UDP to the N1. Then I need to set a null. I need to create null agent for what? So I need to create the null agent, which is the destination for the UDP. So again, which node will be acting as null agent? It is again attach agent. Which node will be acting as null agent? It is the N3 and null. So here if you observe, N3 will be acting as both sync agent and also the N3 will be acting as the null agent, wherein N0 will be acting as the TCP agent and N1 will be acting as the UDP agent. Now let us create the application. And what is the application we are going to use? As usual, CBR. So set CBR new application traffic CBR. Yeah. Then so I need to connect that CBR application with the TCP agent. Attach agent, sorry, not TCP, UDP agent. Yeah, so I'm done with the creating the agents and attaching. So now let us connect those agents together. So I'll say that connect agents. Connect agents. So remember which agent to connect to which. So that is what? So $NS. So I need to connect which. So I need to connect TCP with what? With the sync. Again, I need to connect UDP with the null. Yeah. So therein, so I just connected the TCP agent and the UDP agents with the null agents. So that's what I'm just done with that. So then next, let me go for the, so till now I'm just only dealing with the connectivity. So next is that the last part of, not last part, the next part of the question itself. It says that you need to fix the packet size and the time intervals. So packet size for the TCP it is 200 bytes and the time interval is 0.01, wherein the UDP it is the 300 bytes and the time interval is 0.001. So let us fix that. So I'll say that time interval. So I need to fix the time interval and also packet size. So packet size and time interval. So let us fix that right now. So how to fix it? So again $FTP. So for this I need to fix this packet size underscore, how many bytes? It was 200. Again, what was the time interval? It is the set interval underscore space 0.01. Again for UDP. So what was the UDP service? It was CBR. Yeah, CBR set packet size as what? 300 bytes, wherein CBR set interval as what? 0.001. So I hope you are clear with till here. See, now this is what I can say. This is the end of the all setting up everything whatever it is going based on the question. But now let us have one more extra point here, because as we are going to deal with the two different communications, so there will be two kinds of traffic flow over the same topology. So if I don't do, so what I am trying to tell you in the sense, so the kind of flow which will be in the form of a black and white color in the simulation part. So it will be a black and white. So if you want to make it different, so you can set the color. So I'll say that color setup. So what is this color setup? It's so simple, there is nothing to worry. So I'll just say that NS, I'll fix the first color as red. So I'll fix the second color as so I'll fix the second color 2 as something like green. So I just made the two different colors for differentiating the two different flows, two different traffic flows. In my means to say that what I'm saying in the sense, as we have the two traffic flows, which is one TCP and one more UDP traffic flow. If I don't set up this color, so you can visualize the simulation in the form of a black and white. I am just changing it so to make it visualize better or differentiate better, so I'm just setting red and green color. So here I can set up something like, so for TCP let us set the first color, which is the red color. So I can say that class underscore 1. So what happens, the TCP flow will be appeared in the form of a with the red color. So wherein the UDP set class underscore 2, I'll say. So wherein now it will be appeared with the green color. So that is just to differentiate. So if you don't do that, it looks like a black and white, and it is very difficult for you to differentiate which is the TCP flow and which is the UDP flow. That is the only reason we are setting this. Next, let us go with the last part of the program, which is the setting the procedure. So finish procedure. So finish, open, close, again open. So then I should have a global parameter. So global, I'll set as n. I just made use of three variable point of ns. Again I had trf and I had namf. Then I need to execute, that's what, flush everything. So I'll say that flush trace. Then I need to execute. So I need to execute all. So I need to execute the nam file for the nam for user visibility or visualization. Then I'll be closing everything. So I'll just close $namf and I'll close the $trf. Finally I'll exit 0. So this is the end. So now let us go for the last part of my program. So what is given here, you can see here the CBR should start at the 0.1 and the FTP should start at the 0.3 seconds, and both should wind up at 5 seconds. So that is what we are going to set up at the end. So what I will do, I'll just say that $ns, so at 0.1, and which to start, it is the CBR start. So wherein $ns at 0.3, so I need to start the FTP. Yeah, so what is that? $FTP start. So then both I need to end both at 0.5. Sorry, it is 5 seconds. So I'll say that 5.0 both. It is, I'll say that FTP stop. Again the same way you should have $ns, yeah, at 5.0 CBR stop. So finally I'll be finishing my simulation. I'll just finish my simulation at some time, which is, let me take up more than that 5. So let me say it as 7 seconds. So I'll just say that finish. I'll be calling the finish procedure. I'll be calling the finish procedure, and finally I'll need to call the run. So I need to run this. So this is what the complete program. I hope you understand. So based on the problem, how I divided into the different pieces, in the same way I just developed the TCL script. So now let me save this and let us run this. So I hope you know what the command to run is. Just to ns followed by the 2.tcl. So here, yeah, I'm done with I got a few errors right here. Now let us clear those errors. So what are the errors? It is with respect to the okay, yeah. So yeah, this is where it is not flood, it is flush. Yeah, then I hope that's the error which I got. So now let me check it out. Yeah, I'm done with that. So now you can see this is how. So in this, remember 0, so 0 is the TCP source and 1 is the UDP source and 2 is the intermediate node, which is the router, and 3 is the destination, which is to collect that data. So now let me trace out, and remember if you could able to get it from our program as well. So the bandwidth between N0 and N2 is 10 Mbps, which is wherein the other two links. So the bandwidth is of this is 10 Mbps, whereas these are 10 Kbps. So comparatively I can say it as very huge compared to this. I can say it is more than 10 times. It is more than 10 times I can say, because see, this is what the 10 Mbps and this is 10 Kbps. So even while running also you can visualize that you feel that here the data transmission will be so faster compared to this. That's the first observation you should make it out. So let me run here. So the CBR UDP source started sending at the point 1 second, whereas this is going to start at the point 3 seconds. And also you can observe this is the acknowledgement which is going back to the TCP, and you can see this is the so fast, how fast it is happening, whereas here it is very slow because the bandwidth of this is only 10 Kbps, wherein the bandwidth of this is 10 Mbps. So you feel that, so here the data transmission will be so faster compared to these two links. That's the first point. Second observation which you should make it out here, see, for every data packet which will be transferred from TCP to the router, so for that there is a reverse acknowledgement, you can observe. So this is what there is acknowledgement for this, because this is the TCP communication. This is TCP communication. For every TCP packet you send from the source to the destination, there will be a acknowledgement back, wherein this is the UDP service. For the UDP definitely there will not be any acknowledgement. So that's why we call it as unreliable communication in case of UDP. That's the second observation. So third observation which I want you to make it out from this, it is, so from the TCP you can see there is no drop of the data. With respect to the TCP service there is no drop of the data, whereas for the UDP service you can see there is too much of data drop. The reason is very simple. In case of TCP, until unless you get the acknowledgement for the current packet, it will never send the next packet. So it will be keep waiting in the TCP node itself, source node itself. So it is not simply sending data, or it is not simply throwing the data out. Wherein in case of UDP, it doesn't bother about the acknowledgement for the previous packet or not. In what I mean to say, the UDP source will never bother about whether the current packet is successfully received or not. It will be keep sending the further packets continuously. So in such case, in the unreliable case, so there will be a possibility of drop of the data. See, now you see, as you reach to the 5th second, as soon as you reach to the second 5 seconds, the communication will be stopped with respect to both TCP and also the UDP. So that is what we set up in our program as well. So as soon as it crosses the 5 seconds, so it is going to stop the communication. So this is what the simple observation which is supposed to make it out. So now let me go to the trace file and let us see what is there, what is available in the trace file. So what was my trace file? I had given in the program also. If you remember, see, from my program, this is the name of the trace file which I had given, which is 2.tr. So let me open this gedit space 2.tr. See, from this, again for this again I repeat, so you not understand this in detail, this traffic flow, everything I had explained in the first video, which is the beginning video, which I told you to go through with that video. So please go through that video, then only you can understand these fields as well. So this is what the event, so which is the plus is NQ, minus is DQ, so where is D is the drop, where there will be R with the receive. Now before that I want you to make sure this is the time which when the event is occurring. This is the time, this is the second column which you can see, this is the time, at what time it has occurred, and this is the node. This is the node number 1 and the node number 2, and this which packet. See, and this is the size, this is the packet size. I hope you remember the CBR packet size we set as 300 bytes, whereas the UDP, which is the FTP packet, which is set as only 200 bytes. So from this I want you to make it out. So till the 0.3 seconds we set as only a CBR, because your CBR will begin at the 0.1 second and till 0.3 seconds only CBR will be there. So after 0.3 seconds, given the FTP will start or the TCP will start. So I can make it out from this. You just keep observing till here. So it is only at every time only node 1 is sending, node 2 is receiving, and what packet? It is a CBR packet, and what is the size of it? It is the 300 bytes. Wherein from the 0.3 seconds, where is 0.3, yeah, see, from here 0.3 service onwards, it is not only CBR, you will have the TCP service as well. Whereas as in case of TCP, based on the bandwidth, it is going to transfer the data in a variable fashion. It is not always 200 bytes itself. Whereas in case of this, whereas in case of the TCP service, so it will be keep throwing the same amount of data every time. It will never vary. It will be keep throwing with the same amount of data. You can see wherever you have CBR, it is the 300, it is a constant one, it will be keep throwing. Whereas, and next thing which I already said, till point 3 it is only CBR communication. At point 3 even the TCP will also begin. It doesn't mean to say that only TCP will be there, CBR will not be there. I mean to say from point 3 both the communications will begin. It means to say that both the nodes will start transmitting, both TCP node and also the UDP node, both will be transmitting at the same time. And next point you should know is that for the CBR, as it doesn't require any acknowledgement, it will just keep throwing the data. Whereas in case of TCP, see, until unless you get the acknowledgement for this 200 packet ID, this is the packet ID, until unless you get the acknowledgement for this 200, so it will never send the further packet. So I can show you that with respect to the further. So see, you can see the next packet. So still it is the 200 packet with the packet ID with the 200 only. It is not getting incremented until unless you get the acknowledgement for that. So that let me show in the somewhere else. There will be acknowledgement packet. So yeah, so this is where you can observe. See, there is the acknowledgement packet from where? From the node 3 to the node 2. So for that the source is 0.3, whereas the destination is 0. Because the respective acknowledgement packet is traveling from 0 to the 3, respective acknowledgement should travel from 3 back to the 0. What about in case of CBR? CBR, it was traveling from the 1 to the 3. So it is what? The source, and this is the 3 is the destination. So it was traveling from 1 to the 3, whereas the TCP, it was source packet from the source TCP packets travels from 0 to the 3. Respective acknowledgement will be 3 back to the 0. So like that this communication will be continued. So I hope you are getting. So the first field is the first field is the event. So whether it is the NQ or DQ or the drop of packet, this D means drop. So you can see, this is what I say with respect to the CBR, as it is keep throwing the data, you can see how much data is at every time the data is getting dropped, D, which you can observe. So you can observe that DDDs. So wherever there is a R, so it means to say that the data is received. So wherever you have R like this, if there is a R, it means to say the data is received. Whenever there is a D, which is the drop data, and plus is nothing else, NQ, queuing into the buffer, whereas minus is DQ, where you are retrieving out of the buffer. So that's what the trace file. So I hope you understand the concept. So even the programming also is so easy. So based on, first try to understand the complete problem in detail, and based on that itself you start coding a level by level or a piece by piece. Okay, this is the second experiment, and the experiment, it is termed as this is the complete experiment description. For this description itself we have generated the TCL script, and we observed the traffic flow, and also I had just given the overview of the trace file details as well. Thank you.